Okay, here we're going to go over the solution to this example projectile motion problem, and it starts out by giving you the initial velocity of 30 meters per second at 60 degrees. And as you can see, when I started my solution, I know that I'm not going to be using this 30. I want to get it into its v initial in the x direction and v initial in the y direction values to help me problem solve this problem. For all of our projectile motion problems, we are going to use no air resistance whatsoever, so acceleration in the x direction will always be 0, and the acceleration in the y direction will always be only due to gravity, negative 9.8. Okay. Projectiles are in free fall the whole time. Remember from chapter 2, one-dimensional motion, free fall means that gravity is the only thing acting on it. So if we want to know the total time of flight, we will always focus on y direction for total time of flight because it goes up, it comes down. So delta y is 0. It started at 0, ends at 0. Notice I'm using my initial velocity in the y direction, the 26, positive 26. The initial times time plus 1/2 at squared, negative 9.8. I get one equation, one unknown. I factor the t out of this equation. Certainly t equals 0 is a solution satisfying the equality we have here, but t equals 0 corresponds to where the object started, and indeed it did start at y equals 0, so that's a valid answer, but we are going to focus on the total time of flight, so we're going to take the bracketed term, set it equal to 0, and solve for t, and we get 5.3 seconds is the time it took to come back to ground level. What is the projectile's velocity at its highest point? Well, at its highest point, we know that v in the y direction is going to equal 0. That is always true. We will always take the velocity in the y direction when it has reached its maximum y height, because if it hadn't reached its maximum y height, the velocity wouldn't be 0. It would keep going. So there's no new calculation here. We already calculated that the velocity in the x direction was 15, and it is indeed 15 in the x direction when it is at the top. Okay, the acceleration of the projectile at the highest point, and it's not just at the highest point, it's at any point, is x direction acceleration equals 0, y direction is negative 9.8. To me, the most important part of this problem relative to things that could trip you up for quizzes and tests is to realize that the velocity at any point during the flight, so notice we're looking for 3 seconds, and the total time of flight is 5.3, so we're somewhere in between shooting it and having it hit the ground, and what we want to do is calculate its y velocity at that time. So v final equals v initial plus acceleration times time. And notice we get a y velocity of negative 3.4 meters per second. So I know it's past the top. This sucker's on its way back down. The velocity in the x direction never changes, so that remains 15. So when you are looking for the speed of an object, you definitely need to know both the x velocity and the y velocity to use Pythagorean theorem to get the actual speed of the projectile. Excuse me. The final part of the problem is if we want to know the angle that the object is at, we'll have to use inverse tangent and then describe the angle that we are finding, and in this case it is 12.77 degrees below the horizontal. So to me, parts D and E are something you definitely want to focus on, and make sure you are aware of that when you go to problem solve your projectile motion problems. So I hope this problem helped illustrate to you and reinforce the concepts of projectile motion. I think there's a lot here that is good to know because it will relate to other types of problems that you solve that will be similar but certainly not identical.